from the last video we talked about series and current. That really hits number 8 pretty well, the difference between series and parallel circuits. You're talking one path or many paths. That's the biggest difference. But you also talk about the relationships between total current, total voltage in each case. So for the differences between, refer back to that question as well. But let's start really digging into what these things we're talking about. If we're talking resistance, literally it kind of is what it is. The opposition, only because I can't use the word resistance again. The opposition to flow. In our case, flow of charges, electrons. It's how hard is it to push electrons through. If it's harder, it has a larger resistance. When we talk voltage, those electrons aren't going to flow on their own. They need voltage. So it's the energy per charge, literally, energy per charge, right? It also makes electrons flow. And I put that in quotes because it's kind of a simplification, but think of it, this is the cause. This is what makes those electrons flow. Without voltage, they're not going to go anywhere. It's the energy you're giving them to do something, to go somewhere, to change that into light, heat, motion, whatever. The current, put I, this is V, this is R. Current, think like impetus, which it used to be in Latin. Literally the flow of charges. How many charges are going by per second? Flow of charges. So, voltage, this voltage causes current. The charges are not going to flow if you don't have that voltage. So voltage makes it flow, resistance opposes that flow. How hard is it to flow? So think, how hard to make current? How hard is it to flow? Voltage is going to cause that. Which is why to get current, if you have more voltage, you have more current. That's why it's on top. If you have more resistance, you have less current. That's why it's on bottom. I tend to write Ohm's law this way because it summarizes that relationship. When we're thinking resistance, you're measuring in ohms. Nice omega symbol. When you're measuring voltage, electric potential, you're measuring in volts, V. And you're measuring in current, you're measuring in amperes, or amps, A. So, resistance, voltage, current, the relationship between them, that becomes very important. Oh, and I guess number 10, what is Ohm's law? That's it. The relationship between